Hello everyone and welcome to a short demo about application resiliency achieved by Tanzu Service Mesh with the new capabilities of application SLOs and application autoscaling. So what you see right now is the ACME fitness app, and you can see it's connected to the catalog, and I have different products that I can buy. That web page, that application is being stretched between two different clusters. So on the right side you can see Octant. Octant is an open source developer UI, a dashboard for Kubernetes that I'm using to basically demo that environment. I'm connected to my ACME front-end cluster, and I'm in the ACME namespace, and I can see one pod running with one deployment basically in replica set. That pod is running right now with a consumption of 136 millibytes and 2 millicores of CPU. So let's go to the Tanzu Service Mesh and see the global namespace that connects the dots between those two different clusters. And I can see one global namespace with the name ACME. If I will click on that, I will see the formation of that connectivity. So I have an egress gateway, shopping cart, that's the front end that you can see on the right side. And it's basically connected to all the backend services in a different cluster, ACME backend. Now, when I'm hovering above one of the services, in this case shopping, you can see that right now the P99 latency is 883 milliseconds, and there's roughly 45 requests per second for that service. Now what I want to do now is basically create a threshold, create an application SLO that will set the boundary of that shopping front end in 500 milliseconds for the P90 latency. So 90% of the request or the user experience for 90% of the transactions should be less than 500 milliseconds. To do that, I'm going to go to configuration, service SLOs, and I'm going to create a new service SLO. I'm going to call it ACME, and now I'm going to just check box the P90 latency is less than. I want to create that, let's say less than 700 milliseconds. And the service level objectives will say how much percentage of the time should that threshold be met. So if I will do 100% of the time, you will see there's no grace period. There's no breaching that boundary. If I will do 80%, you will see the numbers changing accordingly, and that means that I can actually I can tolerate 4 hours of daily error budget. So let's do 100% because I want to basically demo that auto scaling capabilities, and I will do next. Now I'm going to check the service that I want to basically check, and that's a shopping. So basically what I'm doing is I'm saying that for the front end. Right now I don't care about the back end, but I can do that to different services in the front end or the back end, or I can also create service groups that basically groups together different services to set that same application intended state. So I'm saving that, and now I have a new SLO. If I will go back to my home and my global namespace, I can click on the service of shopping to get more visibility about that service specifically. So let's click on that. Okay, so now I'm in the service view, and I can go to performance and just see what's the performance of the service right now. I can see there's an SLO configured, and the period is 100%, and it should be a P90 SLO, and I will go to that here above. You will see the SLO ACME is enabled, and right now it's in healthy state. You can also see that the traffic was dropping, and that's because I've removed the load generator, and I will now inject more traffic to basically initiate that autoscale and bring it back into the intended state. So right now there's no violation to the policy, and everything is fine. The service is working exactly according to what plans. Now, what I'm going to do now is I'm going to apply a YAML file on my cluster, and that basically going to create an application scale object, an ASD object, an autoscale deployment shopping, and basically that object will state the minimum amount of pods and the maximum amount of pods that I want, in this case 1 and 10, and what's the metric to basically initiate the policy according to, and that's the P90 latency. Scale up on 700 milliseconds, so basically 700 is the limit. If I will breach that, I will scale the shopping deployment to reduce that user experience threshold. And when I will get into 400, it will scale down the deployment back into the minimum of 1, or according to the latency that will be achieved. Okay, so now I'm gonna just deploy that YAML file. So I'm doing that in my console. So I've created my autoscale, and that's of course a CRD, a custom resource definition, that is built on our Tanzu Service Mesh CRD for that autoscaling capability. And now when I'm refreshing the screen of Tanzu Service Mesh, I will see a new graph. That graph will be that autoscale. So the new graph that will be shown here is the one that will show the boundaries of the autoscale. Let me first load the traffic, and then you will see the new graph of that. So I'm increasing the load. Basically, I'm creating right now a load generator that will push traffic. And right now, we're gonna wait for a couple of minutes or seconds for the load to be increasing. Now you can see the graph. So that's a graph of the instant autoscaling. I want to go back into my octant, so you will see that autoscale when it will kick in. But you can see the maximum amount of pods, that's 10, and the minimum amount of pods, that's 1. You can see the latency right now. So the latency right now is 98. It's not a lot. The refresh date or the refresh rate is every 30 seconds. So once it's refreshing, you can see that, there you go, you can see more traffic getting in. And you can already see that I'm breaching that boundary of 700 milliseconds. So you will see that violation in the P90 latency. And you will see that as well here in the error state. So ACME violation on P90 latency. So right now, the SLO is violated and the autoscaler should be kicked in. So it's gonna start according to a grace period that is configured inside that YAML file. In this case, I'm saying that every minute is the grace period for that. So in 1 minute, it will start the autoscale of the deployment and basically expand the number of pods to meet the demand and to reduce the user experience. There you go. It's already doing that. So now you see 2 pods, and you can see the latency kicking in. And you can actually see in that graph also the instant count. So right now it's 1, but the second is already up and running. In the next refresh, you will see 2. There you go. And you can see the amount of, basically the amount of pods is being increased to reduce the time of the response time. And because it's not enough, the threshold is still way above 700 milliseconds, it will keep going and scale that deployment up until it will get to the maximum number of 10. So right now, I'm gonna give it a go. I'm gonna fast forward that, and we will go back once we will be in the maximum load of that. You can see that once the number of pods is increasing, basically the response time is reducing accordingly. So now we are back in the normal state after we got 3 pods instead of 1. Now if the traffic will keep loading, and it will increase the number of pods up until 10 in the maximum. So now let's reduce that traffic into a minimum. Okay, so now basically what I did is I'm reducing the traffic into a threshold where it should scale down or scale back. But as you can see, it's always playing around that response time and number of instances to basically meet that boundary or request of 700 millisecond response time for the P90 latency. You can now see that because the traffic is reducing, so is the number of the pods, and basically you can see the scale down. And you can see that according to the violation period. So when we had violations of the P90, we had the increasing number of pods, and once the violation stopped and the traffic got down, you can see it's reducing back the number of pods into one. That was the demo of application autoscaling and application SLO. I hope it was useful, and see you in the next time.